Hello everyone. In this video, we're going to look at how we find all complex zeros of a polynomial and then write it in factored form. Now let's talk about first some vocabulary in this question. So this question asks us to find all complex zeros. You might say, hey, this problem is complex in general. Well, it's not what this means. Complex means imaginary numbers are included, or we can use answers with I in them. So, solving these problems tends to go in a couple steps. The first thing we want to do is find possible zeros. Now, how do we find the possible zeros? We use our rational root theorem. So the rational root theorem says we look at the zeros of, the factors of the constant term divided by the factors of the leading coefficient. Now, the leading coefficient's just 1, so we only need to look at the factors of 12. Now, we need to look at positive or negative, so we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So if this function has rational factors, they'll be one of those 12 options, 6 numbers, positive or negative. And so next, we start doing some guess and check. We try some of these numbers and see if they work. Now, let me tell you a hint that I look for. I always try 1 and -1 first. And to do that, I'll look at the original function and just look at the different numbers. I have a 2 and an 8, and then 1 and 1 as coefficients. Hey, that adds up to 12, so I bet 1's going to work. Let's check. So I'm going to go ahead and do my synthetic division. I'll remind you, there's a lot of different ways people write this, but it all ends up looking the same. We take the coefficients and write them across the top, and I add down and multiply up. Luckily, multiplying 1 by 1 is pretty easy. I multiply that 3 by 1 and add it up. That 4 up there, get a 12. 12 times 1 is 12, and I get 0. Hey, I'm feeling really good about this. Now the question is, what should I try now? Well, now it's not straightforward, but I will show you a hint here. Notice that all of my coefficients here are positive. So the only way for us to get to 0 is to use a negative number. So now I know the only things I should check are negative numbers. I look at it and I see it's not going to be 1 because I don't get any things that add to 12. So let's try -2. So I bring down the 1. I multiply by -2. So I get -2. 3 plus -2 is 1. 1 times -2 is -2. 4 plus -2 is 2. I get a -4, and I get an 8 here. So does this work? Nope, this is not 0. So I didn't get lucky. But since these are all positive, that's a hint that your number's too high, that nothing higher than that is going to work. So let's try -3. So I'm going to copy down those coefficients again. C1, -3. 3 plus -3 is 0. 0 times -3 is 0. 4 plus 0 is 4. 4 times -3 is -12. 12 plus -12 is 0. Hooray! Now, let's talk about what we've found so far. We've found that two of the zeros are 1 and -3. I'll go ahead and circle those. Now, let's talk about this right here, the 104. Remember, that tells me that after I've factored out the factors that go with 1 and -3, what's left is x squared plus 4. Or more specifically, x squared plus 0x plus 4. So, to find the other two zeros, I can use my quadratic solving skills to solve x squared plus 4 equals 0. We can try factoring. This one is not factorable. You may remember from other algebra classes that a sum of squares is not factorable. So we can do quadratic formula, but I notice I just have one x here. So I'm just going to go ahead and subtract the 4 from both sides. I get x squared equals -4. Now, in past times, you may have seen this and say, hey, there's no real solution. But since we're looking at complex zeros, it's okay to look at non-real solutions. So I will square root both sides here, and the square root of -4 is, that's right, plus or minus 2i. So my zeros are 1, -3, 2i, and -2i. So if I'm going to write my factored form, I can write this as x minus 1 times x plus 3 times x minus 2i times x plus 2i. Sometimes we're told to write it in factored form with no complex numbers showing up. And so sometimes we'll just take that x squared plus 4 we found here and use that to replace the two factors we got from it. And so we'll write x minus 1 times x plus 3 times x squared plus 4. All right, I hope that helps you in trying to factor these polynomials.